Hi guys, my name is Hoang, and today we'll be starting chapter 7, lesson 1, and lesson 1 of chapter 7 is about graphing exponential growth functions. When we're looking at exponential growth functions, we gotta learn the definition of exponential. Exponential is an increase becoming more and more rapid. And if we look at a growth is like we're growing something. Something is growing. It's increasing. It's becoming bigger and bigger in value, or whatever the unit is, or the situation is gonna be. Like my potato plant is gonna grow and grow more and more as the days of me taking care of it by watering it, or making sure it has enough sunlight, would depend on how fast or how slowly my plant will grow. So this equation right here will be the equation to graph an exponential growth. And we can see here that A is going to be the factor that makes our growth factor more bigger, or tend to be make it a, what do you call it, a factor that makes B grow faster or bigger. It's like in chemistry, it's like a like you're having your reaction and then you're adding something to make it more faster. And so that is going to be what our A is. But B is going to be our player or our game changer. It's our growth factor. It's going to make our exponential grow high. It's going to relate. These two relations are going to help decide our growth and exponential growth function. And our key definition is going to be asymptote. An asymptote is a line that a graph approaches more and more closely. As in exponential growth functions, the graph will never reach the asymptote, or in case for our basic equation right here, y equals 3x, 0. Why? Because it is always growing. It never stops growing. That's the problem. So if it touches 0, it's gonna stop, and we don't want that. In exponential growth, it's always growing, or decreasing at time, but it will never stop changing, growing, or decreasing, or stopping any involving actions. So we make sure that we're adding an asymptote to our graph to show that our graph is gonna never stop or reach 0. And remember, a linear function is not the same as an exponential function. Why? Because first, if you look at the two graphs, this is a straight line. Why? Because it's growing at a constant rate. It's not like an exponential growth where, as you can see, that when it's growing, it's changing its direction and path. And you can see it's growing, and it's growing more and more rapidly. The change is not the same compared to this, where the growth factor is going to be the same. And as you can see from the two equations, exponential growth is going to be, our x is going to be an exponent. And how can you tell? Is that when it says exponent, our x is going to be 0. It's going to be our exponent. Well, that's pretty obvious. So, for example, y equals 2 to the exponent of x, or growth, or player. While y equals 2x, that is going to be our slope and rate of change, and 2 is going to be our A, or B. So it's not going to be the same. So let's graph our first exponential growth of this lesson. As you can see here, we have y equals 3x. That's going to be our function that we're going to graph on this plane. And so we're gonna plot some points to graph. So we're gonna use -2, -1, 0, 1, 2, and 3. And some of the x values look like they're gonna be close to each other because you recall from a linear equation that the distance from this point to this point is gonna be the same, but reality exponential growth function, the points are not gonna be at the same distance because it's rapidly growing. So it might be close, this close to this close to that close to far, far, far. So as you can see, when we plot these points, that some of the points will not be showing on the graph because it's growing so fast that the distance increases from one point to another, from a different point. So let's graph. And if you recall from graphing graphing x linear equations, that x is always at 1, so it doesn't change. But when we're doing exponents now, that x at -1 will be a fraction, while x to the power of 0 is going to be 1. And recall from doing that, it's going to be x times x. It's not going to be 2 times that number. Okay, just remember that when we're doing exponents. So we're going to do 3, -2. 3, -2 is going to be 1/9 because you're putting the 3 under the 1 because it's turning into a fraction, and 3 squared. And when you put a negative exponent to the bottom of the fraction, the negative disappears, so it's just a regular exponent but under the fraction. So that would be 1/9. 3 to the -1 is going to be 1/3. 0 to the 3 to the power of 0 is going to be 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9, because 3 squared is 9. Not 3 times 2 equals 6. Not the same. Not linear equation. And 3 to the power of 3 or cubed is 27. And you can see from these dramatic changes from one point to a point, though these are 1s, however, these y values are increasing and getting bigger and bigger each time. So that would be 2 from the distance from there, and that would be 6. As you already can see, it's growing rapidly from, as we can see from this function, and 9 to 27 is going to be 18. And so let's plot these points. But first, wait. We gotta make sure we plot our asymptote, because we want to make sure that when we're graphing our function, that the function will never touch the asymptote. As you can see, 3x later, asymptote, the function of 3x 3 to the power of x is going to be 0, because when you're getting into the negative zone, and this is a positive zone, the graph will never touch this 0, because you can have like an x value of, let's say, -21. It will be around right here, and then the y value will be like 0.00000 something, right? 0.1 or something, and it will never change. It will never hit that point. It will never, because it's always increasing. But later on, we will be learning how to move the graph from up and down or side to side. But right now, and that is determined by, as you can call it, if you plot this one, this will be our going this way and left to right. No, that would be going up and down, and this one would be, this number that the exponent is subtracting is going to go left to right, and let's go up or down. And this will determine where our asymptote is. But for now, if it's 0, our asymptote right now 3x is just by itself. So you can imagine plus 0, and our asymptote will be 0. So at this point, our asymptote is going to be y equals 0. Hooray! And so now let's plot our function. So -2 right here, 1/9 is going to be like 0.12112 or something like that. But we're going to assume it's 0.1. So from 0 to 1, 0.1 would be right here, or 1/9. So we want to make sure we put our label our point. And -1, 1/3, it will be 0.3, so a little bit higher. And that will be -1, 1/3. And 0/1, of course. 1. And 1/3. As you already can see from plotting 4 points from our 6, that you can see the graph is growing. It's not a straight line no more. It's growing because of the exponential definition, where it's becoming more the increase of and the points are becoming more rapid. So the growth of something is becoming more faster. So you can see from graphing that it's growing. And we're gonna do 2/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And our scale is gonna be 1, and up to here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And at this point, we can't plot 3/27 because we can't actually. As you see, my plane is small enough to fit these points, because the value from my plane is up to 12, but as you can see, the graph never stops growing. So, and the distance from each point increases. So right now we're gonna have 3 to 20. We want to plot 3 to 27, but to do so we have to increase our plane to to make a y value on the y-axis to 27 in order to plot that, or even more. But as you can see, if we just connect the points, it's like similar to a parabola, but it's not really. So like that. Oh shoot, that's really bad. My bad. We want to make sure that it looks like, we don't want to make it like that, or these two examples, because this graph shows it stops, and this one is just doing a U-turn, and that's not the case of exponential growth, because it's always growing. So we will be doing that. And there we go. We want to make sure we add our arrows to show it's increasing and it will never stop. And you can see the points are never touching the asymptote. We want to make sure that when you're plotting your points, you never touch the asymptote. And then there'll be some factors where we can have -3x, and that will change our graph, and it'll be actually decreasing. So you'll be doing a mirror flip, so flipping to this side. But as you can see, the y value would change, will be staying the same. It will be, I guess, no, it won't be the same, but then you can see when you plot, it's gonna be like similar, I guess. Similar, because it's just doing a mirror flip. So I will use this point as an example. So if you put y, so we have 1 as our y value and -3. As you can see, 3 to the 0 power is going to be -1. Shoot. Actually, no, let's keep y right now because we want to show that it's flipping. So -3 to the power 0 is going to be 1. But then you see this negative is going to stay there until this changes, because if you do this exponent first, then multiply, and then we add the negative to the 1, and then and y becomes -1. So we're doing a mirror flip, so from here to here. And so basically, we're just gonna learn later on. We're gonna learn how to translate graphs and flip and do whatever cool exponential growth functions do. But for now, we just learned the basics of exponential growth and functions, and recalling from all this lesson, we know that exponential growths never stop growing, and they grow at a rapid pace. The growth factor never changes, and the distance between points are increasing from distance, and that the graph will never touch the asymptote, as an asymptote is a line that a graph approaches but more and more closely, but it never touches. Let me add that. Never touches. Because the graph is also decreasing, but it will never stop decreasing. It will never stop. Graph exponential growth functions never stop. And that concludes today's lesson of 7.1, graphing exponential growth functions, with me, Henry Hoang, the best teacher in the world. But I hope you guys enjoy learning from me today, and I hope everyone in the world become safe from the world epidemic and be protected and follow the health guidelines, because we all know that we all want to go outside and enjoy our lives with people and friends and family and just hang out, but instead we're at home learning math from me, which is even better. Just kidding. But I just hope that everyone is safe from the situation at the moment, and I just hope that we all follow the safety guidelines and health guidelines, so we all can be safe in the world, and everyone can be cured by the COVID-19, and we all can come outside and have fun. But yeah, thank you for listening to me today, and I hope you all are doing safe and well. Bye.